Okay, so we're looking at the second chapter in, or the second section in chapter 1. Vocabulary we've got to go through is ordered pairs. We're going to be looking at graphing and stuff. Well, I should say graphing. We will be looking at graphing in the next couple sections, but ordered pairs. Anybody know why it's ordered? Why they call it ordered pairs? Yeah.
You have to have the X and the Y.
Yeah, but what's it ordered per? Okay, Rene Descartes back in 1700, he's the father of 2D, right? Two number lines, stick them together at 0 and create 2 dimensions, right? X and Y are ordered pairs. They ordered per the alphabet. Okay, so that's why. That's the order of them. That's why the Y didn't come before X. Okay, so there. X coordinates the first order pair. The Y coordinates the second. Number in the order pair, right? The rectangular coordinate system, again, that is the Cartesian plane, right? Rene Descartes. Axes, you got X and Y. Origin, what's the origin? Come on. It's in the middle, but what is it? Somebody says origin, do you know its location? 0, 0. Good job. X-intercept is the place where the line touches or crosses the x-axis, right? The y-intercept is where the line touches or crosses the y-axis, right? So, any questions about those? A lot of that should be reviewed if you're coming in off 97, 98 or anything, or into a math class period. All right, lines through the origin. Any line that goes to the origin does not have a y-intercept. Well, it does, but it's not written, okay? It'll be in the form of this, y equals mx. So if you looked at an equation like this, it's not going to have a y-intercept because the y-intercept is 0 for the origin, right? So you wouldn't put plus 0 out here. Does that make sense? So if you just see y equals something x, you know that it goes to the origin. Vertical lines and horizontal lines. Those are 2 special cases when it comes to linear equations, right? Do you know how to identify them? No? Okay, let's think about this. Every linear equation that we look at, standard form, slope-intercept form, point-slope form, both contain an x and a y, right? 2 variables. Now, special cases, vertical line, x equal to a number. It's 1 variable, right? The variable tells you the axis is being crossed. The number tells you where on that axis is being crossed. Okay, if the x-axis is being crossed, there's not but one particular special case that will cross it 100% of the time, and it's not horizontal. It's vertical, right? Horizontal only touches it 1 time. We're talking about touching it all the time, and that's vertical line. Okay, so if verticals are x equal to a number, horizontals are y equal to a number, right? 1 variable should identify as a special case, right? They say here's an equation, linear equation, but you only got 1 variable. That's the clue. You got to understand what you're looking at, right? So the y is the axis is being crossed. The number is where, all right? So kind of take that little nugget of information away, and it'll be useful. Right? Any questions on that? That's those 2 things are normally the things that sneak up and bite you, because they're special cases and you don't see them as much, right? So there. All right, so we're looking at 2 formulas here. We're going to look at the distance formula and the midpoint formula. All right, the distance formula is as such, right? You're given endpoints of a point x1, y1 and an x2, y2. The distance between that is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, right? Have you ever seen x2 minus x1 or y2 minus y1 before? Yeah? Walker's shaking his head. What you got? Where have you seen it at? Algebra 2. In what context? Finding distance, but where else is it used? Where is the notation x2 minus x1 and y2 minus y1 used? Oh, I heard it. Slope. Good. Yeah, I want to show you something. Okay? Slope is y2 minus y1 over x2 minus x1, right? So slope is really, that y2 minus y1 is really the change in y over the change in what? X, right? This little triangle right beside the y is a Greek letter called delta, right? Which means change, right? So what I'm going to do is this. I'm going to change out this to make it look like this. So I'm going to change my distance formula just a little bit. Is that okay? We're still going to do the same thing. And if it's making you uncomfortable, stick to the original. But I'm going to show you how to work smarter on this, okay? Anybody know where the distance formula is derived from? It comes from Pythagoras, right? So if I went c squared equals a squared plus b squared, and I went, okay, I'm going to take the square root of this. So c would equal what? There you go. See how these coincide there? So that's how it is, right? You're basically finding the length of the hypotenuse, right? Okay. Any questions on that? All right. So midpoint. If I said find the middle of something, what would you do? Huh? Fold it in half. If I gave you a rope and said find the middle of it, what would you do?
Fold it back on itself.
Fold it back on itself. Take the two ends and do what? Put them together and start pulling it, right? You keep the two ends together and start pulling it, you'll find the middle of the rope, right? Okay, so the midpoint equation is x1 plus x2 over 2, comma, y1 plus y2 over 2, right? It's a midpoint. It's a point. It contains an x coordinate and a y coordinate as the answer. That's what most people forget when they're looking at midpoint, okay? So really what this is doing is it's averaging the x values, x coordinates, right? There's two of them, so therefore they're adding them together and dividing them by what? 2. And then they're averaging the y coordinates, right? Adding the two y's and dividing by 2. So we're going to do this, but it's going to look a little bit different. We're going to do the same procedure, but I'll show you how to keep making some simple mistakes. Because when you're dealing with a distance formula and the midpoint formula, what do you think are the common mistakes that you would see? Huh? Getting them confused, meaning putting a y2 over here and x2 or flipping them, right? Yes? Y'all remember that? Okay, so I'm going to show you some things to keep that from happening. All right, any questions on that? All right, so let's rock and roll. Find the distance between these 2 points. So, ladies and gentlemen, I said that I was going to make my distance formula be this, right? Change in x squared plus change in y squared, right? The change in x is nothing more than x2 minus x1. Change in y is nothing more than y2 minus y1, right? We all agree on that? So, there. How do I do things that keeps errors from popping up? How do you work smart when it comes to math? Well, there's a process that's called stacking. If I have to take and group my x values, or if I have to group my y values, if you stack them one on top of one another, guess what is lined up? Yeah, the x coordinates are lined right on top of the x, and the y coordinates are lined up right on top of the y. Now, I'm needing the change, correct? Okay. Change means this. How far is it between these two things, right? How far are they between these two coordinates? So if I start at -2, how far is it to 3? 5 spaces, right? Now, I want you to think about it. Wherever I start, it's really not going to matter for the distance formula because we're going to square it, right? So the positive and negative, which would refer to distance direction, either going up the number line or down the number line, really it's not going to come to effect when we come into this, right? Because we're going to square and everything's going to be positive. But I want you to still put a sign because we're going to do this when we do slope. Okay? So it ties in very well. So this would be going up the number line 5 spaces. So over here would be a positive 5. You agree? All right. What would be the change for y? Huh? 12. How'd you get that? Can you always do that? No. Because that's a negative 7, right? And that's a positive 5. I add those together, I should get negative 2, right? All right. It's really the difference between. Right? If you look at it, it's x2 minus x1, right? The difference between 2 points or 2 coordinates is how far it's apart. That's how you do that. So from negative 7 to 5, if you'll think about this, if you ever go from a negative to a positive, I want you to think about 0. How far is it from negative 7 to 0? How far is it from 0 to 5? Or 7 to 5? Thank you. We're going up the number line, so it should be positive, right? Ladies and gentlemen, here we go. This is my change in x is 5. Change in y is 12. So I've got 5 squared plus 12 squared, right? That's 25 plus 144. Gives me 169. Yep. And that 169 happens to be a perfect square, which will result in a
whole number.
Hold on. Shoot, I just done that. Why did I do that? All right, so there, that's 13. Okay, will they always come out to be nice, pretty whole numbers? Nah, they won't. So what happens if you get a radical that can't be, that's not a perfect square?
You don't get a decimal.
You're not going to, they're probably going to depend upon.
On the homework, we had some of the decimals.
Did they want you to put them in as decimals rounded to so many places, or did they want you to put in a simplified radical?
On there, like the long it's short.
Okay. Just, here's the thing. Every problem from these homeworks, that's where your tests come from, right? So when you get to a problem, make sure you understand how to put the answer. And I'm going to go back through every test and look and see mistakes. If they wanted the square root of 12 and you put 3.2 something, then, and the square root of 12 is 3.2 something, then I'm going to give you back credit. Does that make sense? We're not going to get you for forms of the answer. So just make sure that you are knowledgeable of how it's supposed to be in. Fair enough? If it's radical that can't, it's not a perfect square, simplify it, right? Reduce it. Check to see how the program wants you, if it wants you to put it as a decimal, and then go. Any questions about this? What do you think? Anybody seen that before? Yeah, done like that? Yeah? Yes. Yeah? All right. You had some good math. Yeah. All right. Because most people stick with the traditional formula, right? Yeah, I'm not traditional, sorry. But we're going to do some things to make life a little bit easier. Okay. Here's two more points I want you to work on, okay? Find the distance between. So I'm going to give you, I don't know, 45 seconds. Get you started, right? If you're done, check it with your neighbor, right? So about 45 seconds. How'd you do? Were you able to get it, or did you get along the process and like, I hit a roadblock? Yeah?
I tried the stack and it's weird. I like the stack. I do it long.
Do it a long way. It's fine. It's the same thing, right? Y2 minus Y1 and X2 Y, it's just change, right? Yeah. All right, so I stacked them so that I'm not messing up my X and Y's, right? -4 to -5 is one change in the downward or decreasing direction, right? That's why it's a -1. All right? And from 3 to 2 is a decrease of 1 as well. Y'all okay with that? So my distance is -1 squared plus -1 squared, which gives you 1 plus 1 under square root, which would give you square root of 2. If you had to do that as a decimal approximation, that's 1.414, right? Okay.
So we don't need those other numbers
What do you mean those other numbers?
because my answer's wrong. I mean, I have the 0.414, but then I had 21356.
All right, so if I'm dealing with decimals, I'm probably going out to 3 to 4 places, just from a accuracy standpoint. Because if I need to take that and do it, rounding error won't affect it as much, unless we're talking about exponentials. Okay, so just check and see how your program is going to take it. That's the biggest thing. All right, how many of y'all did this little changing X and changing Y stuff? And getting you to drink the Kool-Aid? It's the same as what the other is, right? Well, I wouldn't say it's faster, but you're less likely to make a mistake, right? So, all right. In no means do you have to do it this way. You can do it just like the form. Yes.
Is it bad to say I want to see it done the other way? Could you please?
All right. So here, let me do this. All right, so I'm going to make this group 1 and this group what? 2. So that's x1, y1, x2, y2. What did I do? Did they have, it really doesn't matter, but I'm going to say y2 minus y1 squared plus x2 minus x1 squared. I can't remember which one they had. It honestly doesn't matter, right? So there. My y2 happens to be what? 2 minus y1 is 3. That's squared plus x2 is -5 minus, and that is -4. So when you subtract the negative, it becomes positive, right? Of course, that's squared. So that's going to give you -1 squared plus -1 squared. Ladies and gentlemen, that's 1 plus 1, which is square root of what? 2. Okay. So really the only difference that you're going to see is this. Right?
Yeah, it's just written out longer. It's less mental math, I guess. This way.
No, that's fine. Yeah, no, it's just building on deeper understanding of where things come from, common things, commonality of concepts. Okay? All right, so you got to know how to do the distance, right? All right. So let's look at this. Find the coordinates of the midpoint of AB, right? And they give the points -3, 0, and 4, 3, right? Okay, so the formula is this. For midpoint, I shouldn't do M because that's slope, right? So midpoint, I'll abbreviate that. That is x1 plus x2 over 2, comma, y1 plus y2 over what? 2. So basically take your x's. You can label them group 1, group 2 if you want to, but you're just grabbing both your x's on this. So that would be, all right, so here we go. X is -3 plus 4, right, over 2, comma, and the y values 0 and 3, right? 0 plus 3 divided by 2. So we'll move this up so y'all can see it just a little bit more. Negative 3 plus 4 is what? 1. So I'm looking at 1/2, comma, and then 3, 0 plus 3 is 3, 3. So that's 3/2, right? Now, I don't know about you. Sometimes my brain doesn't work in fractions. So how do I convert those to decimals? Divide them, right? So the order, the midpoint, the coordinates form is 0.5, comma, 1.5. Fair enough? Yeah, if you've taken a geometry class anytime soon, or a couple past years, midpoint's pretty standard. So. All right. So that would be actually, here's a half right there, right? Right there. I said graph it, right? So there. Anybody know how to get it without doing this? No. No, not the distance formula divided by 2. I like that though, but no. When you're dealing with points on a line, you're dealing with change, right? Rise and run. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, right? What's half of 3? 1.5. Go up 1.5. What's half of 7? 1, 2, 3.5. Boom. Take your slope and divide by 2. That's all it is. Okay? So there. That was for free. Anyway, use the formula. It's good. Any questions on that? Let's go to another. Oh, we're not. That was it, right? Yeah? Okay. All right, so let's look at X and Y intercepts. So X-intercept, the one thing that you've got to make sure that you understand when it comes to the X-intercept is this. What is the value of Y? If you got a point on the X-axis, what's the value of Y? 0. So anytime that I write X-intercept, I always write right underneath it, Y equals 0. It doesn't matter if I'm working a problem or anything. Reason being is that helps me to understand where it's going to go, right? So we've got to find the X-intercept, we've got to find the Y-intercept. The Y-intercept is a point on the Y-axis, right? What is the value of X? 0. So that's the information that I grabbed, or nugget of information I grabbed for that. So I want you to watch this. We're going to take the first one, okay? And when we find the X-intercept, that means we're going to substitute 0 in for Y, right? So 3x plus 2 times 0 equals 6. So 2 times 0, it goes away, right? So I'm left with 3x equal to 6. Divide both sides by what? So the X-intercept is equal to what? 2, but it's really 2 comma what? 0. That's right. It's a point. People forget it's a point, right? Now, let's go find the Y-intercept. 3, if the X is 0, I substitute 0 in for X, plus 2Y equals 6. 2y equals 6. Divide both sides by 2. The Y-intercept equals what? 3. But really, it's 0 what? That's right. So you're solving for it, and then you're putting it back as an ordered pair. So that in itself is how you find X and Y intercepts, right? So you have 3 more problems. Fair enough? So here's what we'll do. I want this side of the room to do the second. Fair enough? So I got 6 people right there. I want these first 2 rows to do the third one, and then the last 2 rows to do the fourth one. Okay? We'll give you, we'll give you a minute, because I want you to check with the people that are right beside you. Okay? So do that. Okay, so we proved when you solve for the x-intercept that y goes to 0, right? And when you substitute it into the equation, it goes away. Y'all agree?
Mhm.
And we proved here, mathematically, that when you solve for the y-intercept, that x equals 0. When you substitute it, it goes away. Correct? So I'm going to show you something. What I'm about to do. If I were to if I want the x-intercept, I want y'all to do it because hands quicker than I. Watch it. If I want the x-intercept, then I know the y is going to go what, guys? So what if I cover it up? What am I left with? 3x equals what?
6.
Isn't that what we got over there in blue? Aha. Okay. If I want the y-intercept, who goes to 0?
3.
The x value, right? So cover that up. What's my equation?
2y equals 6.
Aha. So we're going to use the cover-up method. Mathematically, we proved it. It's a known that's going to go away, right? 0, girl.
Okay.
X, y, intercept.
Okay. Okay.
That's why. Because of the understanding of the intercept, right? We know there's fixed values that are 0, so you can do that.
Okay.
So you can basically skip this step and go straight down to the second. And know, I mean, that's how teachers can do it in their heads real quick. We're not smart. We just know all the little tricks, right? So, let me do this. I should have kept the x-intercept over here, right? There. Intercept y equals 0, right? There. That's my nugget of information. So when I do that, the y value goes away. It leaves me 3x equals 2. Divide by 3. So x-intercept equals, guess what? 2/3, which is 0.66, right? 7, right? And then we go to y-intercept. That means the x is going away. That leaves me with 2y equals 2 for the second one. Divide both sides by 2. The y-intercept equals what?
1.
And that is 0, 1, right? All right. So, this side of the room, did you see your mistakes? Let's go.
So that means like roughly,
Huh? Do you have to convert it to a decimal? Depends on how the program wants you. Depends on how flexible it is with the number format, right? So, and that's you doing it on the homework, right? All right, so let me do this, and then I'll do this last one, or the third one right there. That's the x-intercept, like that. And that's y equals 0, so I've got 3x equals 3. So x-intercept equals what? 1, and that's 1, 0, right? Okay, good. And then the y-intercept, x equals 0, right? So this thing's going to go away. So that's 2y equals 3. So y-intercept is going to equal 3/2, right? Which is 1.5. I just, you can leave it as a decimal, or you can put it as a fraction. Just, all right. Any questions on that? Y'all good? Make a little bit more sense now? Cover-up method works. Pretty cool. All right. Okay. Rocking right along. Find the x, y intercepts for the following equation. Use the intercepts to graph the equation. How many of y'all have ever used the x-intercepts, y-intercepts, or the intercepts period to graph from the standard form of an equation? Just one, two, couple. How many? Most of y'all listen. Honestly, most of the teachers, if they give it to you in standard form, they say graph it. They want you to change it into what? Slope-intercept form, right? Yeah. Okay. So traditionally, that's in a high school setting, that's what the tendency to do. They really do not stress graphing with x, y intercepts. So what we're going to do is we're going to find the x-intercept real quick. And then we're going to find the y-intercept. And then we're going to graph them. Why is it that we can graph using the x and y intercepts? Huh? They're points. Okay, that I can pull points A, B, C out of the air. Why is it that I can use those two? Looking for a specific answer. No. Huh? No. A line, unless it's vertical or horizontal, going across the x, y axis period, right? Vertical and horizontal is only what's going to cross both. Unless it's strictly on the axis, right? So, why is it that we just graph those? Huh? No. Folks, how many things do you need in order to plot a line? At least 2 points, right? A line is made up of at least 2 points. So if you give me the x-intercept and y-intercept, does that not constitute 2 points? Yes. You know that ordered pair? Driving it home, x and y intercepts are ordered pairs, right? They're 2 points. Okay. All right. So I'm gonna hush. I'm gonna let you find it, and I'm gonna let you graph it. You can find it. You can graph it. You can do it. Ah, food. Come on. All right. So looking at my equation, if I'm looking at this, if I substitute 0 in for the y, it leaves me with 6x equals negative 12. So the x-intercept equals negative what? 2, which is negative 2 comma what?
0.
All right, good. The y-intercept is x equals 0. So that leaves me with 2y equals negative 12. And the y-intercept equals, guess what? Negative 6, which is 0, negative 6, correct?
Yes.
Okay, good. So I'll put these in here. Suffice that. Yada, yada, yada. Okay, so let's go plot a point. Negative 2 on the x-axis. Right there. Negative 6 on the y-axis. Well, we've got to move the screen down, right? Okay. If I do this correctly, voila. There's my line. Okay. Obviously, we able to.
It can help us here. I get nervous when I look at a graph.
Okay, if we got to use the intercept to graph this function, they've changed the game a little bit, have they not? Those silly rascals. They went in slope intercept form, didn't they? I tell you what. Well, you ought to know right away what this number is, right? What is negative 3, ladies and gentlemen? The y-intercept. If you've been around a slope intercept form, ladies and gentlemen, the number that comes after the x is the y-intercept. So the y-intercept here is negative 3, which is 0, negative 3, right? Any questions about that? All right. We're not going to do anything different when it comes to the x-intercept other than we're going to plug in zeros where they're supposed to, right? Okay? So here's the equation. We're going to plug a 0 in for y, and we're going to solve for x, right? So we're going to add 3 to both sides. So 3 equals negative 3x, and of course, huh? Do what now?
You're going to divide that negative 3.
Negative, yes, divide by negative 3, yes. So x would be what? Negative 1, but it's really the x-intercept, which is negative 1 what? 0, right? So, where would negative 1 be on the x-axis? It'd be to the left of 0, right? Mm-hmm. Yeah, all right. Woo-hoo. And we know the y-intercept's what? Negative 3, right? Yeah?
Yes.
But, okay. Y'all raising up. Does that help? If I need to raise the screen, let me know, okay? The sad part about it is we can't turn these monitors down because, all right, there's about 15 different ways we can probably work this one right here. It's okay. What happens if you have an equation that goes through the order? We talked about that, right? You're not going to have a y-intercept. Well, you will, but the y-intercept's what? 0. So if you've got to graph this by using the intercept, what the heck are you going to do? Well, if it goes through, hold up. If it goes through the y-intercept is 0, then the x-intercept's what? 0. So can I even graph it using the intercept? Huh? No. Good. So how am I going to graph it?
Just put it down. Right?
You can. Yes.
Something's not gonna involve the three.
Okay. Pick a point. See, when you have to graph something, and you've got an equation, the old tried and true key table is still valid, right? Yeah. So you need to understand that you can still pick a point. And most of y'all are going to probably pick what? No, 0, 0 is already a point, right? 1, right? And you're going to get a decimal. And you're going to cry because you got 1/3, right?
Don't use three.
Okay. Why do you say 3?
Because the denominator is going to be in one.
Okay. So here's what you got to understand about fractions when it comes to slope and numbers to use. When you have a denominator, let's say it's 3. If you're doing multiples of 3's, then you'll come out with an even. I say even. You come out with an integer. Okay. So if it's in 3's, 0, 3, 6, 9, blah blah blah, that works, right? If it's in 4's, if it was like 1/4, the slope is 1/4, then 1 would be a quarter, the answer would be 0.5, 2 would make it 0.5, 3 would make it 0.75, 4 would make it a nice little integer, right? 4, 8, 12. So if it was 1/8, then I'd look at what? 8, 16, 24, right? To make it hit. If not, I'm dealing with crazy fractions. Y'all agree? So just kind of know that. That's kind of number sensitive stuff on equations. So that's pretty good. So we already have a point, 0, 0, right? So we got it here. So I'm just going to pick 3. And if I pick 3, 1/3 of negative 1/3 of 3, ladies and gentlemen, is what? The y is -1, right? So 3, what? -1. I think they wanted you to put what you used down there. I don't know. Maybe. Graph it, line by finding point other than the origin point. And we did. And it's in, we picked 3, multiples of 3's. How else could you do it? Slope equals -1/3, right? So I go down 1 and to the right, how many? Y'all remember that? If it's positive, I go up, but I'll always go to the right. Always. You go right, you won't go wrong. Fair enough? Any questions on this? How many of y'all, most of this is a review? Refresher? Yeah? Okay. All right. It's going to take off. The first unit's there to kind of check your foundation, right? And then we're going to punch the gas stuff on content. Yeah, don't sweat it yet. Okay. Graph a line. Stop graph a line. Good. Graph a line that passes through 2, -2, and has an x-intercept that's 3, 0. Well, we can graph it, can we not?
Yeah.
Yeah. So how am I going to graph 2, -2?
Go right to and down to.
Do you know where you start when it comes to graphing a point period? You start in the origin, right? The origin is the beginning. You go to that x value, 2. Now, the only choices I got from there is either to go up or what? Down. So I'm going down to what? -2, right? And then boom, that's my stopping point. Okay? So there's my point. Boom. And then I have an x-intercept at what? 3, 0? How are we going to find what is the y-intercept in this line?
You look how far behind that there.
How did we get there?
Left, one down. 2.
Woo-wee, all right. So I want to show you something. Highly recommend doing this. Because this is probably the most easiest, right? Less work. You got 2 points. All you have to do is say, how much did I move in the y's, right? How much did I move? I moved 2, right? Down 2, right? And how much did I move over here? 1, right? Right? So if I were to back this up, I would go down 2 and over what? 1, down 2 and over what? 1 more, right? So that would be my line. I'd have to do the opposite of what's there. So if it's, let's see, it's a positive slope. So I want to fix it real quick. Let's take this, there, take that off. Fix that, don't put it as a -2. Normally you would go up 1 and over how many?
2.
No, wait, I just wrote that backwards. Nobody called it except me. 2 over 1. Yeah, sorry. Up 2 over 1, right? If you ever have to switch gears and go in reverse, then both things flip, right? Up 2 now becomes what? Down, right? And the right one now becomes what? Left. Fair enough? So, yeah. So the y-intercept on this is what? -6. Questions on that? Good. Thank you. All right, is that the last one? Oh man, that's the last one.